purpose of this video is going to be to help you to understand the underlying logical structure of deductive arguments, and we're going to move towards learning how to understand basic deductive logical forms. Now, in order to do this, the place we need to start is with a concept that is known as a logical connective. So what is a logical connective? We'll have the following definition. A logical connective is a word that connects two sentences or propositions in such a way that it determines the truth value, that is, the truth or falsity, of the entire sentence as a whole. Okay, now that's a somewhat abstract definition, and to make it more concrete, I think it helps to look at some examples. So, as we're going to see in a moment, there are 4 different logical connectives we're going to talk about. But for the moment, I want to focus for these examples on the words and the word or. These are both logical connectives, and I'll have a few more things to say about them in a moment. But first, I just want to look at how they're used in the following sentences to explain to you what a logical connective is. So let's look at sentence 1. There are 465 days in a year, and Abraham Lincoln was the 16th President of the United States. Okay, compare that to sentence 2. There are 465 days in a year, or Abraham Lincoln was the 16th President of the United States. Now, one thing you'll notice about these sentences, if you compare them, is that they're very, very similar. In fact, there is only one difference between these sentences, and that is, while the first sentence has these 2 claims, right? The claim that there's 465 days in a year, and the claim that Abraham Lincoln was the 16th President of the United States. It has these 2 claims, and it connects them with the word and. Sentence 2 has the exact same 2 claims, but it connects them with the word or. Now, why does this matter? Well, suppose someone asked you, okay, or you asked yourself, let's say, are these sentences true or false? Now, that's not a difficult question to answer because everything in these sentences is essentially common knowledge, right? So if we take a look at the claims made in the sentences, we all know that there are actually 365 days in the year, not 465, so we know that claim is false. And we know it was true that Abraham Lincoln was the 16th President of the United States, an easily verifiable fact. So we know the truth values, we might say, or we know whether those individual claims are true or false. But what about the sentences as a whole? Well, notice now here's a difference. The first sentence is false. Number 1 is false, whereas number 2 is true. Well, why? What is the difference? Well, sentence 1 is saying it is true that there are 465 days in a year, and it's also true that Abraham Lincoln was the 16th President of the United States. But of course, both of those claims aren't true. Only one of them is. So when we use the word and we're saying both are true, that entire sentence as a whole is false. And it's false because of the logical connective. And to see this, compare that to sentence 2. Here you're just saying, look, one of these things is true. Either there are 465 days in a year, or Abraham Lincoln was the 16th President of the United States. Now, we know there aren't 465 days in a year, but that's okay for this sentence as a whole. It's just saying at least one of these things is true. And despite the fact that the first claim it makes is not true, the second is true. Lincoln was, in fact, the 16th President of the United States. So that means sentence 2 is true as a whole. And the reason I use this example is it just illustrates to you the importance of logical connectives. Right? The way that we combine different claims together with different words, with different logical connectives, is going to have an impact on the overall truth value or the truth of the falsity of the statement as a whole. And as we'll see, understanding and being able to identify these logical connectives is also going to be crucial for your ability to understand different logical forms. So now that we have a general understanding of what a logical connective is, let's take a closer look at the 4 specific logical connectives that we will be concerned about in this class. And those logical connectives are and, or, not, and if-then. Now the first 3 are a little simpler, a little more intuitive, so we'll spend a little less time on those, and then we'll spend a little more time on if-then, which is a little more complex. So let's start with the logical connective of and. So the question we're really asking ourselves is, what does the word and tell you? From a logical point of view, what does it mean? So let's say you have a sentence like P and Q. What does that sentence imply? It implies that both sentences that are included in that statement, that means sentence P as well as sentence Q, both of them are true. So when you use the word and, you're not just saying that one of those is true, and you're not just saying that the other is true, you're saying that both are true. And if both are not true, then the sentence as a whole, the statement as a whole, is false. Now, the example we used previously, one of them used the and connective, and so we can think about that sentence as a substitution of the form P and Q. So there are 465 days in a year, we could call that P. The word and is connecting that to another statement that we'll call Q. Abraham Lincoln was the 16th president. Right? So that sentence, there are 465 days in a year, and Abraham Lincoln was the 16th president, is one substitution, it's one example of the form P and Q. And of course, there are infinite others you could come up with. Ryan is an excellent logic teacher, and aliens live on Mars. That would be another example. Right? So any sentence that uses the word and that connects two things and says they're both true would use the and logical connective. Okay, now let's compare that to or. So let's think about the sentence P or Q. If you say P or Q is true, what are you saying? Well, from a logical point of view, what you're saying is that at least one of those sentences in that set is true. At least one of the things being connected by or is true. So that means P could be true, or Q could be true. Actually, from a logical point of view, they could both be true, although we won't really get into that. But what it's telling you, at least, is that both of them are not false. At least one of those is true. And that's what the word or means in this case. Here are two options, at least one is true. Now again, one of the sentences that we used previously used the or logical connective. So the other example we gave, there are 465 days in a year, or Abraham Lincoln was 16th president of the United States. That's a substitution or an example of the form P or Q, where we could allow P to be there are 465 days in a year, and Q to be Abraham Lincoln was the 16th president. Again, you could think of many, infinite amount of examples that would fit this form. Any sentence that connects two propositions with the word or would be an instance of the or connective or the either P or Q form. Okay, so that's the or operator. Again, and says that both things are true, and or says that at least one of the things being connected is true. Let's look at a third operator, which we haven't mentioned yet. And so this connective is called not. So let's say we have a sentence like not P, right? So what does that mean? What is that saying if you say not P? If we're using the not logical connective, then what we're saying is that P, whatever that sentence is, whether that sentence is there are 465 days in a year, or Ryan is the king of the United States, whatever that sentence is, you're saying it is not true. Here's another example. Today is not a Wednesday. Well, I'm currently recording this on Saturday, January 16th, 2021, and so it is in fact true to say that. It is in fact true to say that it is not a Wednesday. And how is this a substitution instance? How is it an example of the not P form? Well, in this case, what is P? P would be today is a Wednesday. And the word not, all it is saying is that claim, that proposition that today is a Wednesday, it's saying that claim or that proposition is false. And so again, any sentence where something is denied or said to be false would fit that form. If you say today is not a Thursday, if you say Abraham Lincoln is not the current president of the United States, those would also be examples of sentences which use the not logical connective. Let's recap what we've established thus far. So far we've talked about three logical connectives, and, or, and not. we saw that and means that both of the statements being connected are true. Or is saying that at least one of the statements being connected is true, while not is saying that whatever statement the not is referring to is saying that that statement is false. This leaves just one final logical connective that we have to talk about, which is the if-then logical connective, and this is also one that's going to take the most explanation. So the first thing to say about if-then statements in this logical connective is that these kinds of sentences or statements are referred to as conditionals. And in a conditional or if-then statement, in logic we give each part of the statement its own name. So let's look at an example of an if-then statement. For instance, if God is perfect, then God is omnipotent. And if you're confused about what omnipotent means, it's just a fancy philosophical word for all-powerful. So the sentence is just saying if God is perfect, then God is all-powerful. Now, in logical terms, when we have an if-then statement of this sort, the first sentence or claim, right, the one that the if is referring to, we call that the antecedent. And then the second part, which the then is referring to, we call that the consequent. So each if-then statement has an antecedent, and it also has a consequent. Now, sometimes you'll see conditionals symbolized with an arrow, right? So if we have a statement if P then Q, sometimes it'll be symbolized as P arrow Q. And in this case, when we're talking about the general form of if P then Q or P arrow Q, if we refer back to our original example, we would say P is God is perfect, and the Q is God is omnipotent. Again, if P then Q, this is a general form, and this particular example is just one example of that. There's many, many different types of conditional statements, or many examples of them. So you could say, if it is raining, then the street will be wet. If I'm hungry, then I will go to the store. If a figure is a triangle, then it must have 3 sides. All of these would be conditional or if-then statements. Now, just as with the and or logical connectives and the not logical connective, the real important question is the following. When you make an if-then claim from a logical point of view, what are you saying? What is the logical meaning of a conditional or an if-then statement? So an if-then or conditional statement implies 2 things, and in order to understand the argument forms we're going to talk about shortly, you really need to have an understanding of these points here. They're the most important points probably in the video. Okay, so if you have some statement like if P then Q, then that is telling you 2 things. First, it's telling you that the truth of P, or the antecedent, guarantees the truth of Q, or the consequent. So the first thing that a conditional statement tells you is that if you know that P is true, then that is all you need to know that Q is true. The truth of P guarantees the truth of Q. The truth of the antecedent guarantees the truth of the consequent. That's the first thing it tells you. The second thing an if-then statement tells you is the following. It also tells you that the falsity of Q, or the consequent, implies the falsity of P, or the antecedent. Another way of putting this is, if you know that if P then Q is true, then that is also telling you that if you know Q is false, then you know that P must be false as well. All you need to know that P is false is to know that Q is false. Another way of thinking about it is that Q being false makes P to be false as well. Now that's sort of an abstract explanation, so to make this a little more clear, let's look at it in the context of the example that we've been looking at thus far. So we're dealing with the sentence, if God is perfect, then God is omnipotent. Now, before you even evaluate whether such a statement is true, all we're doing right now is asking ourselves, what in the world does that statement mean? So the first thing this statement is telling you is that if you know God is perfect, then that's all you need to know that God is also omnipotent or all-powerful. The statement is telling you, look, once you've established God is perfect, you don't need any further evidence or reasoning or anything else to also know that God is omnipotent. The truth of the claim that God is perfect entails necessarily the truth of the claim that God is omnipotent. So again, in a statement like if P then Q, one thing it's telling you is that if P is true, then you know Q must be true. And in this example, you can see why someone would say that, right? If we imagine that God is perfect, well, that means God must have all perfections. And if being all-powerful is a perfection, it would just follow that God must also be all-powerful. Okay, so that's one thing that the statement is telling you. Now, what else is the statement telling you? Remember the second thing that if-then statements also imply. This statement also tells you if you know God is not omnipotent, if you had some argument that you think established that God is not all-powerful, then it's also telling you that you then know that God is not perfect. Right? Because remember, in an if-then or conditional statement, the falsity of the consequent implies also the falsity of the antecedent. So if God is not omnipotent, that would mean God is not perfect. That's another thing this sentence is telling you. And you can see why someone would say this as well. It's kind of the flip side of what I just said. If we know that God is not all-powerful, and if being all-powerful is a perfection, well then God can't be perfect because that would mean God is lacking some perfection, namely omnipotence or being all-powerful. So again, to put it in a more general form, what if P then Q is telling you is that if Q is false, then you know that P must be false as well. The falsity of Q is all the information you need to know that P is also false. So now that we have an understanding of the 4 different logical connectives, we can now use this knowledge to identify some basic foundational forms of argument in deductive logic. And in this video, we're going to look at 2 deductive argument forms in particular, Modus Ponens and Modus Tollens. Now, first I should back up and say, what is an argument form? What I mean by an argument form is just a structure of argument that, at least in the cases we're looking at here, is always going to be valid. Right? These are just common ways of arguing, common structures of argument that are valid and come up often, and so it's useful for you to be able to determine and identify these structures because of how common they are. Okay, so the first one we're going to look at is called modus ponens. This is a Latin term which refers to the basic structure of this kind of argument. So what is modus ponens? Well, the basic modus ponens format has 2 premises and a conclusion. The first premise is if P then Q. The second premise is P, or P is true. Therefore, we can conclude that Q is true. All modus ponens really does is express the logical structure of the conditional. Conditionals tell us that if we know the antecedent P is true, then we also know that the consequent Q is true. The second premise affirms that yes, actually P is true, and so then we can conclude, and we have enough information to know that the consequent Q is true as well. Now let's look at some examples of this argument form in English to make this a little less abstract. Both of these come from the book. So let's look at example 1, premise 1. If there are no chance factors in chess, then chess is a game of pure skill. There are no chance factors in chess, therefore, chess is a game of pure skill. Again, we can see why this is a valid argument. The first premise says, look, all we need to know that chess is a game of pure skill is that there are no chance factors. It's saying, look, if there are no chance factors in the game, then the game must be a game of pure skill. P2 then affirms that actually there are no chance factors in chess, so therefore we can conclude that chess is a game of pure skill. So we can see it's a valid argument form, and all it does is express the logical meaning of a conditional or if-then statement. Let's look at a second example of a modus ponens argument. Premise 1. This one also comes from the book. Premise 1. If drivers on cell phones have more accidents, then drivers should be prohibited from using them. Drivers on cell phones do have more accidents, therefore, conclusion, drivers should be prohibited from using them. Again, very simple, follows the modus ponens format. First, you say, look, if drivers on cell phones have more accidents, then we should prohibit them. P2 establishes that yes, that antecedent is true. Drivers on cell phones do in fact have more accidents. Therefore, we can validly derive the conclusion that drivers should be prohibited from using them. Both of these arguments are modus ponens because they both follow that argument form. If P then Q, P therefore Q. Now, one other point I want to make about modus ponens is that both of these arguments you're looking at are valid, right? That means if the premises are true, then the conclusion will be true as well. And every single argument that follows the modus ponens format will be valid also. Doesn't matter what the content is, the structure is always the same. It's always going to be a valid argument structure. However, that's not necessarily to say that these arguments are also sound. Remember, to be sound, an argument must not only be valid, but must also have all true premises. And to see this point, let's take a look at example 2. So take a look at premise 1. This is a controversial premise. Some people might agree, some people may not. If drivers on cell phones have more accidents, then drivers should be prohibited from using them. Now, there's no question about whether this argument is valid, but is it sound? Well, that's going to depend on what you think about P1, for instance. It's going to depend on what do you think is the scope of government? What sorts of things should we punish people for or prohibit? How much risk should we accept in society? And those are all propositions that you would have to discuss and debate. So whether or not the argument is sound depends on what we think about that. But what doesn't depend on any discussion or debate is the fact that both arguments are valid because they follow a valid argument form. Now let's turn to a second form of valid argument that involves a conditional. This form of argument is called Modus Tollens, and as you'll see, it's sort of the mirror reflection of Modus Ponens. So what is the structure of Modus Tollens? Well, just like Modus Ponens, in the first premise, we start out with a conditional or if-then statement. Premise 1, if P then Q. Premise 2, not Q, or Q is false. Therefore, we conclude that P is false, or not P. And right, again, the idea behind this is simply sort of the opposite of Modus Ponens. Here we're saying, well, what else does a conditional tell us? A conditional doesn't just tell us that if we know P is true, then Q is true. It also tells us that if we know that Q is false, then P must be false as well. So in the first premise, we have the conditional, if P then Q. In the second premise, we deny the consequent. We say that the consequent is false. Q is false. Therefore, that must imply that P is false as well. Now again, let's look at how this abstract argumentative form can be fleshed out in some arguments in the English language. So here's one example. This example also comes from the book. Premise 1, if the visitor were a stranger, then the dog would have barked. Okay, so what is it saying? It's saying, look, these two claims are tied together. The visitor being a stranger implies that the dog would have barked, right? A sign that the visitor is a stranger is that the dog, in fact, is barking, right? If the visitor were a stranger, we would have a barking dog. But wait a minute, in premise 2, we don't have a barking dog. Premise 2 says, wait a minute, the dog did not bark. Therefore, the visitor must not have been a stranger. Right, so again, you can see the way the argument is moving. First, we say that if the visitor were a stranger, the dog would have barked. Then we deny the dog was barking. So that's what allows us to conclude that the visitor was not a stranger. That's what lets us conclude that the antecedent of the original conditional is false. Let's have a look at a second example. This one doesn't come from the book, but is based on the conditional statement we were looking at earlier in this video. Premise 1, if God is perfect, then God is omnipotent. But then premise 2 claims God is not omnipotent. Therefore, God is not perfect. Same sort of structure. We have an initial conditional. If God is perfect, then God is not omnipotent. But then we say, well, wait a minute, God isn't omnipotent. So this allows us to validly conclude that God is not perfect. So both of these follow the Modus Tollens argumentative form. If P then Q, not Q, therefore not P. Now again, I'll say the same thing about this argument form that I did about Modus Ponens. Although Modus Tollens is always a valid argument form, right? If both premises are true in this form, then the conclusion must be true as well. doesn't necessarily mean that the argument is sound. So again, let's take a look at example 2. A premise that many people would find controversial is, let's look at example 2 and see that a premise many would find controversial is premise 2, God is not omnipotent, or the claim that God is not all-powerful. Now, if we accept P1, if we accept that God being perfect means that God must be omnipotent, and if we accept that God is not omnipotent, then of course it follows that God is not perfect. But that just is to say that the argument is valid. But whether this argument is sound depends on whether that claim at P2 is actually true. Is it actually true that God is not omnipotent? Does God lack some power? Some people would say that God must lack some power and is not omnipotent. Other people would say, no, wait a minute, God is all-powerful. And again, just like in the previous case, that would entail a lot of discussion, debate, and philosophical argumentation. So to determine whether the argument is sound, that's what we would need to engage in. But to determine whether it's valid, all we need to do is to see that it follows the Modus Tollens argument form. So with these points in place, I now want to talk through one of the exercises that you'll see on the book and one of the skills that will be important for you to have for the first quiz. And namely, that is taking an argument that's written in sort of paragraph or prose form, breaking it down into its structure, and identifying what fundamental deductive argument form that it has. I'm going to go through one of these examples, and this is an example that comes from the practice exercises in the book. If you look at the PDF document that I'm talking over right now, which can be found in the description of this YouTube video, you can see a few more examples, which I won't talk through. And in the book, there's also some explanation of further examples as well. But I'm just going to talk through this one example so you get the idea of what you should be doing here. So let's say I give you an argument, again, written out in sort of normal prose paragraph form. So here's an argument. It's actually adapted from an argument that Aristotle gives in his Nicomachean Ethics. So here's the argument. If money is the most important thing in life, then we will pursue it for its own sake. We do not pursue money for its own sake, but rather as a means to achieving something else. Thus, money is not the most important thing in life. So how do we break this argument down? A couple points here. First, start with identifying the conclusion. What is the argument attempting to show you? Okay, well in this case, we can see the conclusion is money is not the most important thing in life. How do we know that? Not necessarily because it comes at the end of the argument. In fact, in many cases, a conclusion may be stated at the beginning or even the beginning and the end. Our main indication here is the word thus. This is an argument indicator. It's telling you that what comes next is a result of the preceding premises. So money is not the most important thing in life. That is the conclusion of our argument. And I have that down here in the argument structure. Once you've identified the conclusion, then identify the premises. And it seems natural here to think that the preceding two sentences would in fact be the premises. So one premise is a conditional if-then statement. If money is the most important thing in life, then we will pursue it for its own sake. So let's put that at P1. Then we're left with the second sentence. We do not pursue money for its own sake, but rather as a means to achieving something else. You'll notice that I only have part of this sentence highlighted as really being the premise. Why is that? Well, the main premise being used here is we do not pursue money for its own sake. Now, why is that? What is the purpose of the rest of this sentence? It's actually giving you a reason or further argument or sort of further explanation of the premise. Right? The reason we don't pursue money for its own sake, Aristotle says, is because money is always a means for getting something else, for getting a car or a TV or a house or going to the movies. Right? You don't want money just to have money, you want it for something else. So this part of the sentence is really just giving you a reason to believe the premise, but it's not actually the premise itself. So this part of the sentence, we do not pursue money for its own sake, which is actually the premise, we'll put here at P2. Okay, so now we have our argument outline, and then the question just is this Modus Ponens or is this Modus Tollens? In this case, this argument is a Modus Tollens argument. Right, if you look at P1, it's giving us a conditional. If money is the most important thing in life, then we would pursue it for its own sake. But then P2 denies or rejects the consequent of that conditional. It says we do not pursue money for its own sake. The claim that we pursue money for its own sake is false. Therefore, based on the Modus Tollens argument structure, we can conclude that money is not the most important thing in life. So here, in addition to identifying the structure of the argument, you can also label it as a Modus Tollens argument form. It follows the same form as the other Modus Tollens arguments we looked at previously. Okay, again, so I hope that gives you some guidance for what to do in those exercises. If you have any questions about any of the concepts in this video or anything else, please feel free to let me know. But for now, I will stop here. Thank you for listening, and I'll see you next time.